Before you start lesson 17, make sure you complete test D on reducing fractions. It's just really important. That's a really important test to do and to do well. Lesson 17 is about measuring angles. Now back in lesson 7 you learned about angles. You learned how to name them and the different kinds, the acute, the right, the straight angle, the obtuse angle. Now when we draw an angle, it's difficult to say how big that angle is. Now we know that that angle that I just drew is bigger than this angle. We can just look at those and tell that one is bigger than the other one. But how do we describe the bigness of them, the quantity? We need to put a quantity, some numerical value, to describe how one is bigger than the other. I mean, both of those are acute angles, but how much bigger is the one on the left than the one on the right? We don't use measurements like inches or feet or anything like that to describe one being bigger than the other. We use something called degrees, and it's not temperature degrees. Obviously, it couldn't be temperature. One of them's not warmer than the other one. It's just a measure from here to here or here to here, and the way you can figure that measurement out is by using something called a protractor. Now, to understand the quantities involved with these degree measures, the way we measure angles, let's look at perpendicular lines and therefore right angles. Anytime you have two perpendicular lines, you can represent that by a little box on the corner there. Now basically two perpendicular lines, those form four right angles, don't they? And they all have a vertex there at the center. Now think about this. Let's draw a circle that has its center at the very middle there. And that circle now is broken up into four sections. A circle, there are 360 degrees in a circle. So what do you think one right angle, how many degrees are in one right angle? It'd just be 360 divided by 4, right? So a right angle equals 90 degrees. Remember in lesson 7 when we compared all the different types of angles to a right angle? We said an acute angle was smaller than a right angle, so that means its measure is less than 90 degrees. An obtuse angle is larger than a right angle, so its measure is greater than 90. But it's not as big as a straight angle. Remember, straight angle, that would be two right angles, so it's 180 degrees. A straight angle has a measure of 180 degrees. So all angles, whether they're acute, obtuse, right, straight, what we do a lot of times to describe the angle measure or to define it is we make a little circular arc right there, because the circles and the angle measures, they have that degree measure in common. Just think about a clock if this is confusing. You could think of the two rays of an angle as the two hands on a clock, and as they move around they form different angles, right? And they move around in a circular rotating pattern. Now we still need to figure out how to measure the angle, how to give it a numerical value, and that's where a protractor comes in. If you don't have a protractor, you'll need to go ahead and get one. I mean, they're not even $1. You can get them at Walmart or probably at your grocery store. You'll have to use a protractor in several of the lessons and probably your tests too coming up. So go ahead and go get one. You might even want to pause the CD and go get one and start back up. Most likely though, if your family's been homeschooling a while, that you've got one somewhere around your house. So go ahead and go get it. A protractor looks like those pictures in the book in this lesson. You know, it's kind of like a semi-circle or half-circle shaped piece of plastic, and it's got angle measures on it. And what you do is you put the center of it, you can usually tell there's a little hole right in the middle on the bottom, and you line that up like let's look at this obtuse angle down at the bottom here. You would line it up with the center of the protractor right on the vertex of that angle, and then you just read it right here. You would read it right there. Now, most protractors, they have like from 0 to 180. It'll start at 0 on this side and go over to 180. But then they also have it where you start from 0 on the left side and go to 180 on the right. There's two different sets of measurements. As long as the bottom angle or the bottom ray is going out to the right side like this one is, you read the 0. You go from 0 to 180. So you'd be starting with the 0 on this side and reading over, and whatever measure it told you where that second ray intersects the protractor, that's what you read, and that's what you would record as the measure for that angle. And you just need to think also when you're doing these different measures using your protractor, look at the angle first, and you can just usually tell, is this an acute angle? Is it an obtuse angle? If it's acute, you know it has to be less than 90. So there shouldn't be any question there. If you get 120 for an answer, you know you did something wrong because you can just look at it and tell it's acute. Or if it's obtuse, you know your answer has to be greater than 90. So think, use that brain God's given you as you do these problems, and just make sure your answer makes sense. Let's go ahead and work some practice problems. I have an example protractor on the board there, and several different angles to measure. And remember, you define an angle by 3 points, and the vertex is always the middle point. So the vertex is the same for all of these. It's always point O there at the center of the protractor. And that's always how you measure using a protractor, right? You line up the protractor on the vertex. And then one of the rays has to go straight out to the right or straight out to the left. Now the first three angles to measure, one of the rays goes straight out to the right. And so whichever one is the horizontal one that's lined up with the bottom, that's where you start with 0 on your measure. So let's just go ahead and measure angle AOB. And you start at A, and you just kind of start going up. That's 0, 10, 20, 30, 40, and it goes right through 50. And so measure of angle AOB, that's equal to 50. Now we don't just write a 50 and leave it. We're doing a measurement here. All measurements have a unit with them, and we put a degree symbol, 50 degrees. And you know that we're not talking about temperature here, so it's the same symbol that's used for temperature or for angle measures. That's why you use a letter as well to represent the temperature, like degrees Fahrenheit. You don't just put a degree symbol, you put degree capital F for Fahrenheit. Now why don't you try to figure out the rest of those angle measures on your own, and then turn the CD back on and check your work. Well, the measure of angle AOC, that's a right angle, isn't it? Because it goes straight up and down. Ray C is perpendicular to ray A, and it goes right through 90 anyway, so that's why we know it's a right angle, because its measure is 90 degrees. Now angle AOD, that's an obtuse angle, and we know that that has to be greater than 90, so we're not going to put 60 for the answer. We always start from the right side. Since one of our rays goes through on the right side, we start at 0 over there and come up to 120 degrees. Now the last three, angle or ray E is our ray that goes out to the left. It doesn't go out to the right. So we start at 0 from the left side and go up. So if we wanted to measure angle EOD, we're going to start from the left and use the numbers that are on the outside, 10, 20, 30, 40, 50, 60. It goes through 60 degrees. And that would be our answer for measure of angle EOD. Then EOB, just look at that. You can tell that EOB is an obtuse angle, so we know that it's going to be greater than 90, and we can just count on over there, and it goes right through at 130. And so there's our answer there, 130 degrees. Now the last one, the measure of angle EOA, that's just a straight angle. Straight angles have a measure of 180 degrees. And you can just tell that on the protractor. You could count if you wanted to. Starting at E, go around 0, 20, 40, 80, 100, 160, 180. 180 degrees is the measure of angle EOA. On the next three, I want you to use your protractor to draw those three angles. Now, to draw an angle, you just need to think about what is involved, what are the parts of an angle, and one of the most important parts is the vertex, right? So what you should do first is just put a point to represent the vertex, and then you can draw one of the rays, and we'll draw the ray out to the right. Then you take your protractor and you center it right on that endpoint, and make sure that where the ray comes out, where it like intersects the end of the protractor right here, that it's lined up on the 0 degree mark. Otherwise, you're not going to get the correct measure. Then what you do is, like for this one, we're trying to do 35 degrees. So you find 35 degrees and you just put a point right there. Then you can take a ruler, or you can make a guess if you want to, or just if you're good at drawing, you can just draw from the origin straight on through that point, and there's your angle. Take your protractor away and you can put a little angle measure mark in there, and you could even label it 35 degrees. So you draw an endpoint and a ray, line up your protractor on top of that. Make sure the ray is passing through the 0 degree mark on the protractor. Then put a point at whatever the angle measure is. Starting from 0, you count up from 0. Then you draw your other ray going from the center or the end point through that point that you drew, and you've got your second ray for your angle. Make sure your angle makes sense. 35 degrees, you should know that should be an acute angle because acute angles are less than 90. And so we have drawn that one correctly. So why don't you go ahead and do the other two, and then you can turn the CD back on and see if you got them right. 87 degree angle would look about like that, just a little bit less than 90 degrees. And the last one, there's a 130 degree angle, and just think about it, that's greater than 90, so it has to be obtuse, and that does look like an obtuse angle that we have drawn there. And so that gives us confidence that we did it correctly. Angles are really important in drawing things, in designing different objects, whether it's a building or a truck or whatever. So it's really important to be able to measure angles and to create angles and draw them as well. Okay, well that's all for lesson 17.